How many times have we all waited for big billion day sales to buy the latest iPhone? Or very recently, we queued up digitally to buy tickets to our favorite concert or Coldplay. How do you think companies behind the scenes are able to run these massive sales so flawlessly? Sanjeev Dangi is an architect at Myntra. Welcome to the podcast, Sanjeev.
Yeah, thanks Atif for having me.
How do we actually test for this volume of traffic? Our systems are going to be healthy.
You can be ready for everything, correct? But nothing is 100% foolproof.
Absolutely.
Every sale is different. There are a lot of unknowns, lot of variables that has moved. It is a game of probability. Very far off, I see quantum computing coming there.
And when you talk about compute is just going up and up and up and up and up. Hi everyone, welcome to the very first episode of Techies by Mercari. Techies is a podcast where we break down the latest tech trends, innovation, and solutions that are shaping up India's digital future. In the past decade, internet penetration has increased, smartphone adoption and usage has rapidly increased, and this has transformed the way that we shop, the way that we communicate. Most of us today and most of our society today shops online. This has created opportunities for big companies to create this mega sales which bring in millions of customers. Think about it. How many times have we all waited for big billion day sales to buy the latest iPhone or our favorite iPhone? Or we have waited for big fashion festival to refill our wardrobe? Or very recently, we queued up digitally to buy tickets to our favorite concert of Coldplay. How do you think companies behind the scenes are able to run these massive sales so flawlessly most of the time when millions of users pour in at the same time? That brings us to our first episode, Surviving the Surge, Tech Secrets for Big Traffic Days. Today, we are going to take a deep dive into the strategies and tools that companies use to take on the challenges that big traffic brings to them. And who's better than our special guest today, Sanjeev Dangi? Sanjeev Dangi is an architect at Myntra. Welcome to the podcast, Sanjeev.
Yeah, thanks Atif for having me. I think this is a really interesting topic. I think a lot goes behind the scenes when like Myntra or Flipkart or these large companies are getting ready for a very eventful sales that happens like a couple of days in a year. So I think I'm very excited to talk more on this.
Thank you, Sanjeev. So Sanjeev has been the driving force at Myntra for running high traffic operations. He has navigated everything from monolith mayhem to cutting edge cloud and microservices architecture. I've been very fortunate to work with Sanjeev in the past. I've seen him build resilient, scalable systems. So Sanjeev, very excited for you to give us all the secrets of how you handle such traffic spikes.
So I have been in Myntra from last 8-9 years, and I've seen a couple of sales. I think maybe more than 10. And I have been part of multiple teams. I have been in platform team, I have been in supply chain team, I have been in store facing teams. And I think the scale challenges, I think as a part of, irrespective of which team you are part of it, you will always face scale challenges when these events are happening, because number of users that are coming are very humongous. And as the traffic penetration also is going more into tier 2 cities because of the internet penetration, every year the scale challenges are increasing. So we need to make sure that we are always ahead of the time in these sales.
So you've spent nearly a decade at Myntra, and I'm sure you've seen multiple sales. What has been that one time where things have not really gone the way that you thought about?
Yeah, so I think sales are really like sometimes people are on their toes. And as soon as, let's say, when we open the gate at 12 in the night, everybody is looking at their screens, like if everything is right. And there'll be always be something that will not go as per the plan. And I have seen a couple of instances. Maybe one instance I will talk about is that like one of our third-party payment providers got degraded. And suddenly, I think we show the payment success through rate of that payment gateway going down. And that payment gateway, we have a very good offer that was running. So like that is one of the instances, but there can be a couple of more. Yeah.
That seems like a tough one. How did customers react to that situation, and how did you guys find out?
So I think like on the readiness point, I think if there is some issue, like we have our monitoring systems that always alert us if a minor issue happens. So we get to know if there is issue as soon as the issue happens. So like the engineers who are on call will automatically look at the issue. Our systems are also very resilient to these kind of issues. Let's say the payment provider has degraded, automatically that payment provider is disabled, and the other payment provider, the traffic shift to other payment provider. And like some intermittent failures may happen if during that switch, but that is okay, I think.
Okay. So in this whole sequence of events, there might have been places where the customer experience might have been impacted a little. How did you go about dealing with that?
Any third party provider can degrade. So this is kind of a normal situation, but during sale, I think you get a lot of first time users.
Okay.
So I think that they may not be very aware of like all the nitty gritty of online payment. So it may happen that a lot of users, like some of the users have their money debited, but now the order didn't went through. So they may reach out to customer care. So I think in those kind of situation, we do proactive communication with all the stakeholders. Like we also, if required, we also send the communication to CC, like detailing out what kind of a response, let's say, customer needs to be told, and if this is very specific to this instance. So at least if a customer reaches out, they are prepared, and like customers is also aware of the situation, and they are well settled that nothing has happened really. So that's how we take care of these situations.
Man, I can only imagine how involved everyone in that war room were during this particular instance. This whole umbrella of scaling, right, or this whole uh, concept of scaling has changed in the last decade. There was earlier this way where you had on-premise data centers, and then we all kind of moved into cloud infra. How has scaling changed in the last decade?
So if I look at maybe 10 years back, I think the whole setup was very different. I think we used to have a lot of monolithic systems.
Yes.
And like a lot of platform capabilities that we have now, let's say the data stores, or let's say any of the managed services you see today, that capabilities were not available, and a lot of heavy lifting, like companies used to do on let's say every company is solving that problem internally first time. So let's say if your system is very monolithic, scaling that become really hard, because now you have to scale that whole system. So we used to vertically scale that, and now let's say today you have cloud. In those days, we need to have this data center providers, and they were not very self-serve like that we have today in the managed cloud. So that the lead time of, let's say, if you want to do any scale up, or let's say the kind of SKU or infra requirement or capabilities that you require, that were limited. So, and in that case, it used to take lot more lead time than today. We can do it much lower cost and like lower time. Another thing is platform capability. Let's say if I talk about distributed systems, we have very few capabilities built on the database side at that time. Now we have native databases which are giving horizontal scalability by default with the different kind of capabilities that you require today. If I took a look at messaging system, Kafka, maybe it came around that time only. Like now Kafka is a messaging infra that is used for horizontally scalability in event driven systems everywhere. So if you look at architecture patterns, I think that time people were figuring out these architecture. They are very standard now. So like the space has become very old. So if I look at from like capability point of view, or this data center provider point of view, or let's say architecture patterns, they have become very old. And the resource capabilities, let's say what you could do with, let's say, CPU capacity, that time you have much larger infra available on your head. But the one thing that has shifted in terms of the scale is like number of users that time were very limited. So that scale, maybe you were able to scale up those infra, but the number of users have also scaled dramatically. So I think that is the shift we have seen from like last 10 years. Yeah.
Got it. So just coming back on the lead time that you spoke about, back then, what was the lead time that you're referring? For example, if I had a sale coming up and I wanted to scale, how much time would it take for me to scale my current setup to how it is right now if I have to scale? I know there's a very good difference now, but what is the lead time before and how is it now?
So I think lead time would depend upon what kind of capabilities you want to provision with that infra provider. So some of the capabilities, let's say if how does this providers works is they have some buffer capacity, but let's say if you require larger buffer, they will talk to their vendor. their vendor like will source from where. So how much lead time from which like warehouse, that capacity, do they have that capacity already in hand, or they need to plan that capacity. So all these things used to like you need to have a couple of discussion and then plan that. Today into the native cloud providers that you have, they have good enough buffer capacity, so you need not to have those kind of conversation, and that reduces your delay time to a larger extent, because number of people who are using this native cloud provider is a very large. So the incremental capacity, let's say if you require 2x of capacity today,
Okay.
they can give you in just a few minutes, correct? Because number of like clients that they are catering to is huge. So maybe your 2x is very minuscule for number of clients that they are catering you. But I think that is the difference I'm just saying.
How has monitoring changed? How we were monitoring earlier to how we monitor today? I know we have a lot of alert systems today. Uh, back at Mercari or back in the past as well, I've seen alerting has become so involved that it hardly takes time today to understand or to know that there's a problem.
Yeah.
Understand, of course, triaging has become more efficient, but how has this whole monitoring and reacting to the situation changed?
So I think one thing that has changed into monitoring is like earlier there were isolated views of the monitoring. Like if a system has like there are metrics that are isolated, logs that are isolated, or let's say infra level monitoring that is isolated. Now the
Yes.
monitoring tools combine all of this information. They give a single snapshot.
Correct.
That is one thing that has changed. Second thing is like now people have shifted to microservices architecture. So you want to have a look of 360-degree view of all your services. So
Okay.
you want to see a first level of snapshot out of these services, how they are connected, and which service has degraded. So you can get a 360-degree first snapshot of that and drill down if required on that data. Correct. So I think that is one thing that has evolved. Second thing that next thing that has evolved is like earlier the alerting was very threshold based. So let's say if this number goes below this,
Yes.
correct? So they were very static and manual. Today, I think alerting is becoming more, I would say, uh, more nuanced in a way that they can identify anomalies into the data points and
Okay.
can send the alerts if that any anomaly happens. They can change the threshold looking at the past pattern of the data if the threshold has shifted. So and the monitoring landscape that today, like we have very standard tools.
Okay.
And earlier I think you need to do a lot of heavy lifting. You need to expose expose a port, and you need
Yes.
to export the matrix. Now like all these platform capabilities are given out of box from, let's say if you use any databases, they have metric as a part of exposed very in the standard format that, let's say, today's metric systems consume. So the basic plumbing you used to do earlier for each component is specific, that is not happening. And let's say the monitoring dashboards are also very standard. Like let's say if you have one component, you have a template, like all the metrics it will show in a templating view. Another thing that actually happens is, let's say if there are a lot of systems and a lot of issues are happening,
Okay.
this like today there are dynamic dashboard that shift. Let's say if there are 10 metrics on that dashboard,
True.
you will push the top metrics which is airing out on the left side. So your widgets will keep on shifting and pushing the data onto the users focus point, so at least they need not to go and do too much homework.
So let's say a holistic view of seeing things in a such a way that things on the monitoring dashboard are rapidly changing based on how systems are changing. I think that's really efficient for someone to take a look at the dashboard and really know where the problem is. I think we've gone a long way in how exactly we look at problems and how quickly we're able to resolve them. And I think monitoring, the way it has changed or how well it has grown, really helps developers to businesses to ensure things are like absolutely rock solid.
Yeah.
Sanjeev, walk us through this whole process of preparing for this mega sales. I know there goes a lot of readiness. When I was at Myntra, I've seen a bunch of things that the team used to do. And then what actually we do during the sale and what happens after the sale. Can you just give us a complete overview of how this whole thing goes end to end?
Yeah. So I think there are multiple steps that go into cell readiness.
Yes.
And Atif, you have been involved in all of these, I think, being a part of Myntra. So the first thing that goes into this is we decide what kind of traffic that we will get during this sale, and
Traffic
that is
first.
dependent upon a lot of things. Like one, let's say, what kind of new capabilities that or new constructs that we are going to launch in this sale. That is one part. Second thing is like what kind of promotions and marketing we are trying to do, and
Okay.
how much of the organic traffic will come and how much of the inorganic traffic will come. And today, I think this whole process we have very automated. So what we do is we look at past sale data, and that gives us some insights into how we get like what kind of traffic that each of the services or let's say our gateway gets.
Okay.
And we also have the data, let's say what new features or capabilities we have built, what kind of traffic that
New features
new capabilities getting today. Maybe that was not part of previous sale,
Okay.
but we have some data to extrapolate. Now we put all of these data into some automation, and that uh, looks at this data and computes the data and projects the data for the next sale.
So primarily, this is how you are basically projecting what kind of traffic you will get for the sale
Yeah.
through various sources,
Yeah.
whether it's promotions, whatever you spoke about.
Yeah.
So that's the first step that you do.
Yeah.
Okay.
So once I think it's decided that this the traffic will get, I think then we do the projects. Like for traffic projection is done. Now we go to one level deeper. Like we have public API endpoints. So how much traffic, let's say, each of the public API endpoints will get if we simulate that user journey as per our traffic projection.
Got it.
So that projection happens. Then the next level of projection, let's say, how much traffic each of the service will get based upon the user journey.
Each individual service.
Yeah,
Okay.
correct. And we project that data upfront. It is very automated and percolated to all the teams. So I think that is one step.
So relatively, what would happen is there would be some services which are, let's say, getting the highest traffic, let's say something like a homepage. But there'll be some services who might get, let's say, that funnel down version of that traffic.
Yeah. So I think top in the funnel you get higher traffic,
Yes.
and then bottom in the funnel you get lower traffic. So and where the engagement is more like search, product page, people spend more time. So I think on every page the traffic pattern changes, and sometimes the traffic pattern may change based upon the new construct you are launching. So
Yes, you
on
mentioned
different page also, correct? So yeah.
So after the projections are done, then you what are the next things that the teams do? Because they really have to. I think now they have to start thinking what kind of resource they need. Right?
Yeah, correct. So I think next thing that happens is like infra augmentation. Let's say last like normal days, this is the X number of users are coming to your website.
True.
In sale, they may be like 4x, 5x, or like I'm hypothetically talking about the numbers, but that can be any X number.
Correct.
So based upon that projection number that came up, we also do hardware augmentation projection for across all the components. So let's say we'll say last sale, or let's say you were using, let's say, X number of boxes.
Okay.
Looking at the traffic pattern, we think this component would require, let's say, 15 boxes.
Got it.
Correct. So that also is very, very automated. We look at the traffic pattern and we project the hardware also across different components.
So you just give numbers to this automation which says this is the traffic that we anticipate. Give us the hardware required for this and augment it also.
Correct.
Provision it basically.
Yeah. So we project the data for augmentation. That is like people look at it if there is some delta that needs to be done just to see if everything is right. The validation is done. After that, augmentation is also automated. Like you want to augment like this much hardware, most of the things are automated. So you click the on the click of button, the augmentation starts, and the hardware is provisioned, and also there are validation scripts that make sure that after the provisioning everything is right or not.
Oh, perfect. So now that we have all the readiness done, and we have projected our traffic, we have augmented the hardware that we need, how do we actually test that for this volume of traffic our systems are going to be healthy?
So I think then I think one thing teams do is they certify their individual components. So if there is a service owner, they have to do the load testing of their components.
Got it.
So they have load testing script. So we have central platform where all the teams do the load testing. As part of feature rollouts, like people keep on augmenting that load testing suite, and
Okay.
based
So they
upon
keep
the
updating this
correct,
always.
yeah,
Makes
and
sense.
based upon the projection that we have given, I think they will change that projection number as per this sale and run these load tests. One thing that we have automated, or let's say to a large extent, is like during load testing, you generate a lot of test data
Yes.
for your dependencies or
Yes.
anything. We have made sure most of our test data generation happens on the click of button. So people don't invest too much time into generation of the test data either for dependencies
Okay.
or yeah.
So it's very important that you have the actual, you are able to mimic exactly the same kind of test traffic as the real one. So for
Yeah,
that, you
correct.
need a test data which is very, very near same as the real traffic.
And I think this is really, really critical from the point of view that if you don't invest into, let's say, if you're doing load testing, what kind of data you are using, then I think you can certify your load test. But when an actual event occurs, you
Correct.
will see very different behavior. So
Absolutely.
I can give you one anecdote. Let's say if you have one service and let's say you get millions of users concurrently on that service, and you that let's say if your cache hit ratio is let's say 70% for your transactions.
Okay.
And then let's say if you only use 1000 users and you run a load test and within a 1 minute your cache is warmed up and you are
Yes.
getting 100% cache hit rate, then
Correct.
you will say I have certified my service, but
It's
eventually
nowhere to real
yeah,
traffic.
correct. So I think test data preparation is really, really critical step from that point of view, and like we review that very thoroughly. Like yeah.
Now let's say the sale is started, right? What goes into what does each developer who is probably on call for that particular service do? What actually happens at that time?
So I think before sale starts, I think what we also do is we plan for like run books for the sale. So there are activities, pre-sale activities, during sale activities, and after sale activities. So we plan those run books. We review those run books, and there will be some engineer or developers who will be doing some set of activities as a part of overall sale execution, and that are reviewed. Another thing that happens is like before the sale starts, we make sure that our infra or our production infra is immutable. So no changes go
Very
go
important, yeah.
into production. So there is a hard block, and let's say some issue is identified. If the need requires, that is reviewed very thoroughly. That change is identified, reviewed, and then only after approval it goes into the production systems. And run books are important from a point of view that during sale you don't have much time. Like you cannot discuss like take half an hour if some impact or let's say some production issue has happened.
Absolutely.
Because number of users coming on your site are humongous, and you can, if you have a outage during that time, you get a very large bad, you may also get a bad PR on the social
True.
media, correct?
Yes.
So that's why the run books are created, reviewed, and to a large extent all the run books are automated. So when an issue happens, the owner is aware like this has happened, this is the run book I need to execute. They at least need to like they at least get discussed, and then only after approval they run it. But I think that is one thing that really smoothens the overall, let's say, execution of these steps.
Correct. And also, Sanjeev, I know for issues that might pop up, we will have run books. But for issues that we don't anticipate, right? How do we ensure we are able to triage it as fast as we can?
Yeah.
Right.
So I think this is really critical. I think it is something like you can be ready for everything, correct? But nothing is 100% foolproof.
Absolutely.
So sometimes you will always see one or another issue that will happen, and then at that time you need to take the steps to fix it. So one thing that generally like we make sure is like if that issue is happening, how do we mitigate the risk for the customer? Like let's say how do we minimize the impact on the actual end customer? So there can be multiple things. We identify whether that flow is really critical, or let's say that flow is impacting customers, business, or any other internal system. Based upon the criticality, we identify what steps needs to be taken. We at that time we generally don't go forward to fix it with a code change then and there unless that is really required. We identify other approaches. Let's say do we have feature flag that can be disabled, or let's say not that functionality will work, but that experience may not be super good, but that is very good for the customer journey point of view. So there may be degraded behavior that customer may see for the time being, if that is acceptable. Or let's say, do we have something else? So let's say, can we do some other intervention? Or let's say we have some recon that is running for time to time, or let's say, so those kind of things we look, and we try to do risk mitigation. And after that, let's say once the sale has gone live, after that we'll do a lot of steps. But let's say during sale also, if it's a P0 issue and that requires, let's say, code fix, maybe in the worst of the cases we'll do it. Correct.
Yes.
But I think that
If
is
it's
the
a business
overall
critical workflow, you have no choice.
Yeah, correct.
What are the steps that you do at the end of the sale?
I think once the sale is gone, I think everybody is relaxed and people look at the revenue numbers. I think you have achieved the targets, and I think
I
the
agree.
sale really went well. But one thing we do that is really critical is like every team captures all of the observation or issues, or let's say whatever hiccups happened during whole of the sale. Each of the issues is identified and captured by each of the teams. They identify the root cause of each of the issue. They capture the required data during the sale that is required for future course of actions.
Makes sense.
And once that is done, within the like we do a central retrospective review of all the issues, where all the architects are there, and they make sure that whatever issues are identified, we identify short-term action item as well as long-term action items, and they bake that into each individual team's plan, and they are tracked with the execution plan. So we make sure that when the next sale happens, let's say whatever issues that were known, that are properly fixed. Even though some new issue can happen, even though we do a lot of preparation, but at least the known issues are plugged in till the next sale happens.
But, Sanjeev, do you think we'll reach an ideal state someday where after a certain mega event, we might have absolute zero outages or absolute zero failures? Because see, we have so many sales, sometimes multiple across a year, right? And we are continuously building systems again and again, making them more robust, making them more reliable. Do you think there'll come a day, at least for the current scope of how, let's say, products are, which requires absolute no human intervention and everything could go smooth? Do you think you see that as a future?
Every sale is different. So what kind of constructs you run in last sale? So there are a lot of unknowns in the sale. Let's say if every sale is very predictable, let's say this is how the sale happened last time, this is how, I'm hoping that everything will, we can make sure that everything goes planned and there will be no issues, correct? So at least that can be done. But at every sale there are a lot of unknowns, a lot of variables that has moved. Because of that, I think sometimes it is a game of probability. I think we have seen sales in Myntra there where there were no issues, correct?
Wow.
So I think that has happened. But I think it's function of, I think, number of moving variables that you have as a part of each sale.
Absolutely. But Sanjay, I want to ask also for viewers' sake, I just want to understand, for folks that are building products today, what should be the principles or fundamentals in mind if you want to make a scalable system today?
There are a couple of things that people can work upon when they design scalable systems. I think first thing is people needs to always have first principle thinking. So I think how, like at the first principle thinking, don't look at, let's say, the tech stack and everything. Let's say if you have to scale something, how would you do it from the first principles? I think that is really important. If you think through that thinking, I think you will be able to leverage the tech that is available in most of the situations. So, and the next thing that comes is, like, when you are designing systems for scale, you need to make sure that you also model your, let's say if you are building something, you model your components with the right segregation of domain. So let's say one component should do one thing well. It should not do 10 things together, correct? So when components are given right responsibility and they do one thing really good, they are able to scale much better, rather than you percolating a lot of concerns into a single component.
So this is mostly separation of concerns.
Yeah,
primarily.
correct.
Okay, that's fun.
Yeah, and
Okay.
today I think microservices architecture is very, very common. So
I know.
like you have lot of services which collaborate and interact to give you high scalable systems. So that is one thing that works for the people, that they are able to give the single responsibility to one microservices, and that microservice scales horizontally as per the need and basis of requirements of that scale. So that is one thing. Another thing is, I think when you are building a high scalable system, the tech choices that you are making is really, really critical. Let's say what kind of framework you are choosing, or let's say what kind of database you are choosing, or let's say what kind of messaging system you are using. So you need to have a holistic understanding of some of the core tech platform choices that you have based upon your scaling needs, or let's say your data consistency needs, and let's say what kind of scalability you require, whether you require write scalability, whether you require read scalability. So I think that is the next part. I will say, like right tech choice is very, very important. I think, let's say if you are using Python doesn't scale that great. Let's say as compared to JVM based languages. Correct.
Yes.
So how much hardware you will throw under a Python based service will be much, much larger than if you implement that on the GRE based language.
I've been in that dilemma sometime. When you're designing a system, it's always efficient to have, or it's always better to have modules have their own ownership and execute their, let's say, whatever workflows that are assigned to them. But what you end up doing with that is you over separate. So what is that balance when you are thinking about separating, let's say, systems in a manner where you don't over separate, nor you make it like a complete monolith?
Yeah. So I think one thing, like in scaling also, people don't do premature optimization, correct?
Okay.
So same principle I will hold. Don't prematurely build microservices unless, let's say, so that domain is very old. So today, like you can have one microservices doing, let's say, that work. Tomorrow, the same microservice may evolve into two different microservices. If, let's say, domain evolves,
I agree.
more functionalities are added into that concern. So today, earlier that was a single concern. Now, if you look at overall functionality, that becomes two concerns. So I think we need to look it very holistically, whether the concern we are looking is, let's say, meaty enough to build a service for that in the first place. So you don't do like proliferation of too many microservices.
How important is it to have very good observability right from the start?
One thing at when you're building something at a high scale, I think one thing people needs to really work is they need to have platform thinking. So what is platform thinking is you build a capability, and that capability can be leveraged across multiple teams, and that scales horizontally.
Okay.
So I think if you want to build, let's say, monitoring stack, and you will be having a couple of services with a high scale, and that monitoring stack will also has to scale for all the infra needs that you have.
Yes.
So you need to make sure that you invest platform thinking in that monitoring stack. The onboarding should be pluggable and easy. There should be client isolation. There should be more self-serve on that, and that should support most of the tech components, observability of the most of the tech components. So I think that is one thing I would just suggest, to have platform thinking on building any of the native adjacent concern that you have managing your infra.
What more after this? Like observability, we spoke about. I think monitoring, like you mentioned, you really have to build the platform stack and think about platform first when you're actually building for scale. What are the next things?
Next thing, I think, when you're building things for scale is like, and it's customer facing, then you need to have redundancy baked into your overall architecture. Like, look at all the components, which component have single point of failure or not, correct?
Yes.
If that goes down, there'll be outages or not, correct?
Yes.
So that is really critical. And with redundancy, let's say something goes down, you have to contain the blast radius. Like, let's say the issue should not percolate to everywhere. So you need to have resiliency into your system. So you need to have, let's say, circuit breakers that kick in, and that don't send the traffic to the failed system automatically. You need to have degradation lever. Let's say if I have a service and that has degraded, I can drop non-critical traffic.
Yes.
Or let's say non-critical flow in my website can disabled without impacting the core critical flows. So I think those are some of the things that you need to make sure that from experience point of view, let's say even though degradation happens in your systems with a high scale, at least the core customer experience is not impacted.
There's a very thin line where you kind of think that you need to always have a system available if that fails. So how do you make that choice? Okay, for business critical workflows, you might think more that you need redundancy. But what are the other factors where you really think when you think that, okay, should I be more redundant or not?
So I think redundancy is a factor of, let's say, you need to look at each of your component from business impact point of view. So you identify this component, let's say if this component goes down, what is the business impact I will have? So once you look at from that lens, let's say if I give a score to that component from, let's say 1 to 10, and this comes at 10, means let's say if this system is down, then I think my revenue is 0. So then I think you need to look at, let's say, if the like some component can fail and they keep on failing, then I need to have higher redundancy in that part.
Yes.
And let's say if some component is very low critical, or that is used, let's say some internal ops people, or let's say it is used very infrequently, then it is okay. Let's say you don't have high level of redundancy. Let's say if the issue happens, then that person can, let's say, wait for half an hour, can do that thing, correct? So
Yes.
it is a function of, let's say, how much money you are throwing and how much output you are getting from that money, because nowadays engineers cost is much higher than, let's say, how much additional hardware redundancy.
Very true.
Yeah. So there are one or two more things I will just tell people, like so one thing that is very critical to scale the systems is like you do the minimum work that is required into the user path. Let's say if somebody is doing something, do the bare minimum work and then do most of the things asynchronously.
Makes sense.
So that is like event driven architecture. You, like, let's say if somebody is posting a review, you want to moderate that review. Moderation can happen offline, or let's say via your asynchronous path, but at least you can capture that review and send that response to the user. And there are a lot of use cases of this very simple nuance that you can use in multiple places. So at many places, let's say you generate the recommendations offline, and let's say every couple of hours,
Very good
and then
example.
everything is pre-computed, and when the user comes, you serve those recommendations, correct?
Correct.
So that is fairly straightforward thing, like a lot of companies do.
It might not be very near real time, but
Yeah.
it is somewhere there
Yeah,
because
correct,
you're
correct.
doing it asynchronous.
Yeah.
And it does not really affect the user journey as much as how much we would want to think.
Yeah, correct. And one is another thing that is very critical is like, how do you also do the caching effective in whole of the user path? So you can have caching at database layer, caching into, let's say, outside of your databases. You can
Yes.
have caching into your application server. You can have caching at CDN layer. And caching itself is a very heavy domain. How do you want to optimize your caching at different levels? And how do we make sure that the consistency, data consistency guarantees for the use cases are taken care?
Yes.
So I think that is also very critical from the scaling point of view. In next couple of years, as the things are evolving, one thing is like, as I said earlier, platform capabilities, or let's say managed services that we are getting, they will evolve, and whatever heavy lifting, let's say today we are doing, will get out of box. That is, and let's say the architecture patterns, let's say that got solidified, we'll have new architecture patterns that will get solidified, correct? And third part is, let's say now, like today you want to do personalization for every user real time. I think that is one thing that teams are attacking today, because that requires more compute, more infra. As the AI is becoming like everywhere,
You have the
like,
buzzword.
yeah. So we will see AI being used in each of the systems to make them more performant. Very far off, I see quantum computing coming, correct?
Yeah.
So maybe Google is making lot of strides,
Yeah.
and quantum computing can do lot of compute that, let's say, today you do with very large scale of hardware.
Yeah.
So I think those are some of the evolving things, but they will take some time.
The future for scaling really looks very bright, and I really see the next 10 years, maybe 10 years later, me and you sit down to talk.
Yeah.
I think it's going to be a very different conversation.
Yeah.
With a lot of things like AI agents, etc., coming in. A
Yeah.
lot of these places, in terms of preparations that we spoke about, when we spoke about how you manage things when the sale is going on and the end of the sale, all of this, I can kind of think that AI agents can take over and do a lot of that things.
Yeah.
And when you talk about compute, compute is just going up and up and up and up, and
Yeah.
I think we'll just throw in more use cases. But Sanjeev, I think great insights, man. I think we all will benefit, and we'll apply this wherever we can. But again, thank you so much for sharing all of this.
Thanks, Atif. I think it was a really very nice conversation. I'm hoping that the viewers will like it.
Thank you so much for tuning into our very first episode of Techies, the podcast for techies. Bye bye.